Hello, my name is Brooke Weltman, a researcher at the Carbon Leadership Forum, working in collaboration with the University of Washington for this training series. This is Module 3, Environmental Product Declarations. This is the third of 5 modules in this introductory level training about embodied carbon. Note that I'll reference here concepts from the previous 2 modules. After watching this video, we hope you'll have basic familiarity with the following EPD topics: what they are and how they relate to embodied carbon and policy, the different types, standards that guide EPDs, including PCRs, the EPD development process, how much they cost to make, EPD generator tools, life cycle stages in EPDs, where to find EPDs, and advancing EPDs for policy. All right, let's jump in. What is an EPD? An environmental product declaration is a standardized, third-party verified document that reports the environmental impacts of a product based on a product LCA. So like a mileage rating on a car or a nutrition label on food, they help purchasers compare similar products. But in this case, instead of miles per gallon or calories per serving, EPDs report environmental impacts per declared unit of product. This slide shows a picture of a manufacturer's concrete EPD. EPDs report a product's embodied carbon as its global warming potential, or GWP, expressed in units of carbon dioxide equivalent per declared unit. Here we see a GWP of 268 kilograms of carbon dioxide equivalent per the declared unit of 1 cubic meter of concrete. In the broadest view, there are 2 types of EPDs: product EPDs and industry average EPDs. The most common type are those created by a single manufacturer, which I'm referring to here as product EPDs, though that's not a formal term, and others may refer to these in other ways, like manufacturer-specific EPDs or manufacturer EPDs. In policy, these types of EPDs are important for reporting product GWP to a buy clean or similar policy, and for comparing like products to each other or to a policy GWP limit. Product EPDs are sometimes further classified as facility-specific or product-specific, or by how much supply chain-specific data they use. These are also not officially defined terms at this time, and different people may use the terminology differently. So it's important to see clarity on what people mean when they use these terms. And if you're using these terms, it's important to clearly communicate what you mean. The other broad type of EPD is the industry average or industry-wide EPD. An industry association usually publishes an industry average EPD, drawing upon data from several manufacturers across the market. In policy, industry average EPDs can be particularly important for setting GWP thresholds or limits, since they often draw from a large segment of the industry and have production-weighted results. They can also be helpful for tracking embodied carbon reductions achieved by an industry over time. I mentioned that EPDs are standardized documents. The key standards that govern EPDs are shown here, going from more broad on the left to most specific on the right. ISO 14040 and 14044 provide the principles and framework for all LCA, as mentioned in the Intro to LCA module. ISO 14025 provides rules for environmental declarations of many sorts, including EPDs. Notably, this standard requires third-party verification for consumer-facing EPDs. ISO 21930 serves as the core rules for EPDs of construction products and services in North America. Then finally, the product category rules, or PCR. These give specific guidance and rules for product categories like steel, flooring, gypsum panels, and so on. So an EPD is a public-facing report that provides estimated environmental impacts of a product. And it's based on the LCA, which is the analysis. And the LCA and EPD follow the rules established by the PCR. These rules include, for instance, system boundary requirements and which background data can be selected. PCRs, like ISO standards, are created through an open stakeholder development process, where a technical committee of experts from industry, academia, NGOs, government, and LCA practitioners use a consensus-based approach to create the PCR. PCRs are typically updated every 3 to 5 years. These are the general steps manufacturers take to create an EPD. Step 1, manufacturers must collect foreground data on the quantity and types of materials, energy, and other processes they use to create the product, typically for a 12-month period. Next is conducting the product LCA and preparing reports. This means building the LCA model and, as described in the previous Intro to LCA video, combining the manufacturer's collected foreground data from step 1 with LCA model background data to generate results. LCA consultants typically do this work, though some manufacturing companies have their own staff that conduct the LCA. The LCA background report provides full documentation of the LCA methods, assumptions, data, and standards conformance to support the verification review process, and is typically not made public. The public-facing EPD, on the other hand, summarizes the results of the LCA, but does not include many of the details from the full background report, particularly any proprietary information. EPDs are reviewed by an independent third-party verifier before they're published. The verifier checks that the methods and data documented in the LCA background report conforms to the PCR and other relevant standards. And finally, once the EPD has been verified, the manufacturer can submit the EPD document to a program operator who will process, register, and publish the EPD. They may additionally submit the EPD to a database like EC3, which I'll mention later in this presentation. After publication, EPDs are typically valid for 5 years from the date of issue, though that does vary somewhat by PCR. So how much does this cost? Well, based on discussion with a few organizations that provide these services, we have listed approximate typical costs to the manufacturer for each of these steps. In this conventional model that I've described so far, a manufacturer might expect to pay somewhere between $20,000 and $35,000 for their first EPD, though it really varies quite a bit depending on the complexity of the work and the number of different facilities and products, and would likely be less for subsequent EPDs. A growing alternative to that conventional approach is EPD generator tools. These often integrate steps 2, 3, and 4, where the manufacturer plugs in their own foreground data and the tool does the rest, supplying the background data, the calculation processes, EPD formatting, and pre-verification against standards in order to publish the EPD on demand. These are most prominent today for ready-mix concrete and asphalt mixtures, which have relatively simple manufacturing processes that lend themselves to this type of standardized and streamlined EPD process. EPD generator tools typically involve a single upfront cost to the manufacturer to access the software for a given plant, and then manufacturers can produce an unlimited number of EPDs. So the price per EPD might be somewhere in the hundreds of dollars range, but of course it depends on how many EPDs the company makes. Notably, the EPA recently announced $160 million worth of grants to increase the quality and quantity of EPDs on the market. So we can expect manufacturers' direct costs to decrease for many industries as these grants get distributed. We discussed life cycle stages in the previous module. For most product categories, EPDs commonly have a cradle-to-gate scope. That's A1, extraction and upstream production of the input materials. So for concrete EPD, A1 would include the production of cement and aggregates and additives. A2, transport of those input materials to the manufacturing facility. And A3, manufacturing, which is generally the energy use like electricity and other fuels at the manufacturing plant to process the input ingredients to create the final product. Some PCRs allow the option for additional downstream stages, and some PCRs require a cradle-to-grave scope. These later lifecycle stages are particularly important for product types where there could be significant product-to-product variation for these downstream steps, such as roofing products with different replacement rates or flooring products with different use and disposal scenarios. I'm going to do a lightning quick walkthrough of an EPD to give a quick sense of what they include. So here we see the industry average EPD for cold form steel framing with the declared unit, the validity period, and the PCR on the front page. Turning inside, here's a sampling, including this system boundary diagram that outlines which processes are accounted for and in which stage. Here we see a description of the various products covered in this EPD. Here we see the inputs in the first column and the data sources used to model them for each of those inputs. And finally, we see a portion of the EPD's results, including the GWP in the first row. We see here, for example, that the production of upstream ingredients in A1, which in this case is the galvanized steel coil, that's the main input to cold form steel framing, is by far the dominant contributor to the total cradle to gate GWP of the product. Where to find EPDs? Here are two public searchable EPD databases. On the left is an image from the Embodied Carbon in Construction Calculator, or EC3 tool. On the right is the Sustainable Mines Transparency Catalog. Also, program operators, industry associations, and manufacturer websites also often provide EPDs. I'm going to give a very brief demo on the use of the EC3 tool. Here I am on the landing page. If I want to find EPDs, I'm going to search for a certain product type. In this case, I'm going to choose concrete unit masonry, or CMU. And here you can see there are various parameters that I can search or filter for: compressive strength, different options, GWP under a certain amount. In this case, I'm going to limit my geographic range to USA. I could also choose North America or even down to the state level. Perhaps I want to look only for normal weight CMU. And here I can filter for those that comply with a certain policy. Perhaps in this case, the GSA's best 40th percentile policy limit. Once I have my filters, I can search the database, and the tool will return a list of EPDs that meet the search criteria. So here we see there are 83 product EPDs that meet these search criteria. Now back to the slideshow. So EPDs work as the mechanism for reporting impacts and comparing products for embodied carbon policies to the extent that they are comparable. And EPDs can be appropriately compared if they use the same PCR, the products are functionally equivalent, like concrete mixes of the same strength or roofing products with the same performance and service life. They have the equivalent system boundary, modeling methods and assumptions, and equivalent foreground data collection processes, and equivalent background data. Now, all these items are about, if we look at one EPD's results and compare them to another's, we want to be confident that the difference in the results is about actual differences in manufacturing processes or supply chains, and not about differences in how the LCAs were conducted. And PCRs are really critical to improving EPD comparability because they provide the rules for creating EPDs. So PCRs can support clear labeling of product types and functional characteristics to help determine functional equivalence. And PCRs can prescribe data and methods so that differences in reported GWP reflect actual manufacturing or supply chain differences, again, rather than differences in LCA modeling choices. Finally, some key takeaways. EPDs report product embodied carbon and are based on a product LCA. They're used in policy by agencies to set product GWP thresholds or limits, and by manufacturers to demonstrate compliance. Several standards govern the creation of EPDs. PCRs are the most important of which. EPDs are appropriately comparable if they meet certain criteria, and PCRs can help to advance EPD comparability by ensuring EPDs meet those criteria. There's lots of additional resources on the CLF website, including policy toolkits, research reports, and ways to connect with others interested in reducing embodied carbon. In particular, related to this module, the EPD 101 Policy Toolkit Fact Sheet offers some similar introductory information on EPDs as discussed here. And the Material Baselines report and appendices provide an in-depth and comprehensive state of the EPD snapshot for North America. Thanks for attending this module. Make sure to check out the other videos in this series, and take care.